All right, this little mini lecture is going to look at an example problem with time dilation. And this problem reads, what will be the mean lifetime of a muon as measured in a laboratory if it is traveling, if the muon is traveling at 0.6 times the speed of light with respect to the laboratory? So the muon's lifetime at rest is 2.2 times 10 to the negative 6. So what is it going to be observed as the mean lifetime of that muon when the observer is in the laboratory and the muon is moving relative to the laboratory? So if we were with the muon, if we were moving along with the muon at rest, if we were at rest relative to the muon's lifetime would be on average 2.2 times 10 to the negative 6 seconds. So that's the proper time. That is our time t naught, delta t naught, and the observer in the laboratory sees it as a longer time because of time dilation. So if we look at the time dilation relationship, right, we have the delta t is equal to our proper time, delta t naught, divided by the square root of 1 minus the speed of the particle squared over the speed of light squared. So if we use that full relationship, and now we plug in what we know. We're told that the speed of that muon is equal to 0.6 times the speed of light. And we're told that the proper time is equal to 2.2 times 10 to the minus 6 seconds. I mean, we weren't told it was the proper time. We had to figure that out, right? Because if the event, the lifetime of the muon we were at rest observing it, the muon was at rest, we were traveling with the muon, that would be our mean lifetime. So as we utilize that relationship, we have 2.2 times 10 to the minus 6 divided by 1 minus, and then we have 0.6 squared, so 0.36 c squared over c squared, right? So 0.6 c quantity squared over c quantity squared. And that gives us 2.2, just trying to do the math out for you. So it's a pretty short video. Divided by the square root of 1 minus these two c squareds go away. 1 minus 0.36 is 0.64. And we find that the average mean lifetime of the muon as observed by the laboratory is 2.8 times 10 to the minus 6 seconds. So it's a quick example of using time dilation, recognizing which of the delta t's that we're dealing with, and then getting familiar with those relationships. Good job.